knows a lot about the science stuff. Professor Dave explains.
We just got done examining the form and function of the squamates. Now let's go over their phylogeny. In terms of classification, extant squamates are grouped into about 60 families. Traditionally, they were separated into the three suborders: Amphisbaenia, the worm lizards; Serpentes, the snakes; and Lacertilia, the lizards. But this grouping is no longer used, though the snakes and worm lizards form monophyletic groups, and they both exist within what was once considered Lacertilia. A suitable replacement has been debated for quite some time, with numerous potential phylogenies that are still in flux as of 2024, so let's just summarize some of the main groupings. To start, we can see that in more modern reconstructions, the most basal clades are the blind skinks of family Dibamidae, which are burrower lizards characterized by their elongated bodies with blunt head and tail, and the geckos of infraorder Geckoda, which are small, carnivorous, mainly nocturnal lizards found on every continent except Antarctica. They are widely considered unique for their vocalizations, eyes without eyelids that they often clean by licking, specialized toe pads, and tail autotomy, or self-amputation as a defense mechanism against predators. Note that Geckoda is not a family, but an infraorder, and includes clades such as the wood gecko of family Diplodactylidae, the common leopard gecko of family Eublephaриdae, and the common or true geckos of family Geckonidae, such as the hose geckos, day geckos, leaf-tailed geckos, and many more. The next major group are the skinks of family Skinkidae and their kin, such as the night lizards and spiny-tail lizards. Of these families, the skinks are without a doubt the most diverse, with over 1,500 described species. They are often characterized by their stout bodies and lack of a pronounced neck and small legs, though some lack legs entirely and some do have rather pronounced necks. A third major group includes the small and primarily insectivorous true lizards of family Lacertidae and their kin, such as the spectacled lizards, whiptails, and worm lizards of the group Amphisbaenia, which are highly specialized fossorial or burrowing lizards, whose group is named for their curious ability to move backwards as effectively as forwards. They are further separated into 6 families, such as Bipedidae, which includes the two-limbed Mexican mole lizard; Blanus, which includes the Iberian worm lizard; Trogonophidae, which includes the checkerboard worm lizard; and Amphisbaenidae, which includes the majority of all extant worm lizards, such as the red worm lizard and pink round-headed worm lizards. Next is a proposed clade known as Toxicofera, or venom clade. Many members share very few morphological similarities, but molecular analyses point to their common ancestry. It includes 3 major suborders: Anguimorpha, Iguania, and Serpentes. Anguimorpha includes a wide range of forms, from the American legless lizards of Anielidae and the morphologically similar slow worms and glass snakes of family Anguidae, whose common name is a reference to the ease with which they drop their tails, to the Chinese crocodile lizard of Shinisauridae, the venomous beaded lizards such as the Gila monster of Helodermatidae, the knob-scaled lizards of Xenosauridae, the gallowasps of Diploglossidae, and the semi-aquatic endangered earless monitor of Lanthanotidae, a close relative of the monitor lizards of family Varanidae, which are in the genus Varanus, and includes about 80 species which are recognized by their long necks, powerful tails, sharp claws, well-developed limbs, and venom glands situated in their lower jaws. Many members of this clade are also noted for their intelligence, such as the Nile monitors, which appear to cooperate while foraging in the wild, tree monitors, and Komodo dragons, which appear to play in captivity and recognize their keepers. Next up, Iguania also includes a range of forms, such as the charismatic chameleons, a distinctive and highly specialized clade, noted for their range of colors and ability to shift their hues, zygodactylous feet, prehensile tail, laterally compressed bodies, unique head shapes, projectile tongues which they use for catching prey, their unusual swaying walking style, and the crests and horns of many species. As a family, Chameleonidae appears to be closely related to the dragon or dragon lizards of Agamidae, which includes charismatic species such as the bearded dragons, spiny tail lizards, Chinese water dragon, and frilled lizard, all of which are noted for their well-developed strong legs, stocky bodies, and inability to regrow their tails. Other members in this suborder include members of Phrynosomatidae, such as the emerald swift and horned lizard, the Madagascar iguanas of family Opliridae, the snow swifts and liolamids of Liolamidae, the often brilliantly colored collared lizards of family Crotaphitidae, and the widely dispersed anoles of family Dactyloidae, which are very common in the Americas, where they are sometimes commonly referred to as American chameleons, due to their ability to shift hues, though they are not actually chameleons. They are often small green or brownish lizards, and in most species, the males at least possess a colorful dewlap that varies in color and presentation by species. Still other species include the curly-tailed lizards, the helmeted lizards, as well as the iguanas and chuckwallas of family Iguanidae, nearly all of which are native to the Americas. Though diverse, they often possess dorsal spines across their back, a dewlap on the neck, sharp claws, a long whip-like tail, and stocky body. Despite their appearances, they are typically herbivores that exhibit little to no parental care or aggression, though females often guard nests until their young hatch, and males during the mating season may be temporarily aggressive to members of their and other species. Finally, members of suborder Serpentes are commonly referred to as snakes. All extant forms, which are limbless carnivorous reptiles with highly kinetic skulls, numerous vertebrae, forked tongues, and asymmetrical placement of their internal organs to accommodate their often slender bodies. Granted, snakes, like all amniotes, are tetrapods, though they lack limbs because they secondarily lost them. Fossil forms of snakes with limbs have been found, and pelvic spurs exist in some groups, such as the pythons, though they are considered to be vestigial. Often, their paired organs, such as the kidneys, appear one in front of the other, while other times only one of the paired organs is functional and the other is reduced or vestigial, such as in the lungs of many species, where the right lung is elongated and the left greatly reduced. Though in this tutorial, we've already mentioned quite a few legless squamates, some of which are even commonly referred to as snakes, such as the glass snakes, Serpentes are the only squamates that are considered to be true snakes, which includes more than 25 families. So instead of going over each one, let's explore them by generalized groups, and pay special attention to a few select families. Note that, like the wider group of Squamata, the relationships between specific clades within Serpentes is still debated, though some groupings appear to be more solid than others. For example, the blind snakes of infraorder Scolacophidia absolutely share common ancestry and are considered to have diverged from a basal group of early snakes. All 5 families of the clade, along with the dawn blind snakes, are small in size, adapted for burrowing, and possess reduced eyes covered in scales. A second major group of snakes are booids of superfamily Booidea, that includes lesser-known clades such as the earth snakes, spine-jawed snake, sunbeam snakes, Asian pipe snakes, and dwarf pipe snakes, and also the more well-known pythons of family Pythonidae, non-venomous constrictors native to sub-Saharan Africa, Asia, and Australia, and the boas of family Boidae, many of which give live birth, unlike the pythons, which all lay eggs. Like the pythons, they are also large non-venomous constrictors, though they are found mainly in the Americas and include species like the green anaconda, true boas, and sand boas. Lastly, except for a few smaller families that include the file snakes, false coral snake, and the thunder snakes, all remaining species, or more than 80% of snake species, are in the superorder Colubroides, another major group that includes small families such as dragon snakes, snail eaters, mud snakes, and African house snakes, along with the comparatively more biodiverse and better-known vipers, elapids, and colubrids. These last families include the majority of all snake species, and all known species often considered to be venomous, which in English is different from poisonous, in that a venomous animal must bite something to inject venom, while a poisonous animal is usually the victim of a bite, where it releases poison in response, though this is potentially a bit of a misnomer, since even the saliva of harmless snakes, said to be non-venomous, contains very limited toxic qualities, that, though harmless to humans, may provide evidence for the ancestral state from which venom evolved. An example is the common garter snake that, though considered to be harmless and non-venomous, does produce a small amount of neurotoxin in its saliva, though it lacks fangs to inject it. That is unlike the vipers of family Viperidae, which are characterized by their highly developed movable tubular fangs located at the front of their mouths that they use to inject venom into their prey. These include the most famous venomous snakes in the United States, such as the rattlesnakes, copperhead, and cottonmouth, along with many tropical species such as the Gabon viper, bushmaster, and terciopelo. Often, snake venom is classified as either neurotoxic, acting on the nervous system, or hemotoxic, destroying red blood cells. But most snakes contain venom that is actually a mixture of many substances that are not easily assigned to either grouping. A second family of venomous snakes are the elapids of family Elapidae, which includes a great deal of highly mobile and feared snakes, such as the black mamba and king cobra. All cobras are part of this family, as are the coral snakes, sea snakes and krites, and stiletto snakes. Many species are highly venomous and are characterized by their short, permanently erect fangs at the front of their mouths. Finally, the colubrids are the largest snake family and are found on every continent except Antarctica and many islands. The vast majority of them are small, shy, and cryptic, and either non-venomous or lack fangs and produce a venom in their saliva at diluted quantities that is harmless to mammals. They include species like the rat snakes, American water snakes, common garter snakes, green snakes, ring-necked snakes, and many others. Though they are mainly harmless, there are a few that can produce extremely potent venoms, such as the boomslang and the savanna twig snake, that have fixed venomous fangs in the rear of their mouths. Venomous species in the United States include the coral snakes, though no deaths have been attributed to its bite in over 100 years. One final note on envenomation. The severity of it due to snakebite varies widely by region. In the entire United States, for example, though up to 8,000 people may receive a venomous snakebite each year, less than 5 of those people die. Again, that's not 5% of people bit, that's 5 out of 8,000, meaning that in the US, less than 0.1% of people bitten by a venomous snake will die. Meanwhile, in India alone, venomous snake bites kill more than 50,000 annually, most of which are caused by just 4 species. Regardless, remember that the majority of snake species are harmless to humans and play important ecological roles. And with that, we've wrapped up a quick look at the diversity of the reptiles, or the non-avian reptiles at least. There's still one last clade to cover in this series, the birds of class Aves. Let's move forward and introduce those next.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.